Hi everyone, welcome back to another video where I'll be discussing prototype design pattern. So this is the pattern that I've kept just after the builder design pattern, which is not same as the builder design pattern, neither very similar, but in the sense that the prototype design patterns reduces that manual effort of creating objects, just like how builder design patterns do without exposing constructors. But there are a lot of examples, there are a lot of differences where the prototype design patterns is not same as the builder design pattern, but it does give some somewhat similar feel to that of builder design pattern. So let's understand what prototype design pattern is. But before understanding the prototype design pattern, we have to understand something called as cloning in programming language. So cloning is nothing but copying of objects into a new objects during runtime. So if suppose I have a object such as A during the runtime, I would want to copy and create another object AC during the runtime. Now the thing is, in programming, the object are never stored into physical drives. It is usually during the runtime process or the runtime memory or the primary memory where your program is running. And in that memory, every object holds its values or state in the runtime, as we all know. And if you would want to clone or copy the properties of any object, suppose A to AC, then you would want to create another AC object as a empty object, as an empty object inside of the runtime, and then copy the values or the properties or the state inside of the A object to the AC object. What I'm trying to say is, let's suppose A has two properties inside of it. So in this example, A has two state properties inside of it, X and Y, and they both are having a primitive data type of values which are like 1 and 2. Now you would want to create another copy of this object, A object, in your program, in your runtime. Then you would create something called as AC object, which will have the same values as X and Y. But the thing is, this AC value is like a container that is holding separate values of X and Y inside of the runtime. So here XA can reside in the X1 memory space during the runtime, and the AC will have to reside in X2 memory space, so that if you want to change the value of X going forward, it should not change the values of the X inside of A1 or Y inside of A1. So it should not affect it. So that's how the memories work. So if your X value is stored in the X2 memory space, and if you go ahead and change the value of X inside of the X2 memory space, it should not change the value of X in the X1 memory space. Okay, so this is what cloning actually is. That's why it's not simply called as copying of objects. It is called cloning of objects, where you create a new object, a container object from the original object, copying the same structure, and then copy the literal values from one object in the runtime to another object in the runtime. So that is what cloning means. Now there are two kinds of cloning inside of the programming language. One is called shallow cloning and one is called deep cloning. So shallow cloning and deep cloning has a very minor difference, but let's understand what's the difference between two is. I will take, for example, the same A object into the runtime, and you can have a class A which will have two properties. Okay, so class A has two properties, and in my programming, I created one object which is like A1 in my memory. So it can be done like this. So what I did here is that here in my programming, I created an object A1 which has two values of inside of it, which is X and Y, and X right now has a value of 1 and Y has a value of 2. So this is in its own memory space. We'll just simply, for the sake of simplicity, we'll call it A1. And now suppose I want to clone A1 into A2. So hypothetically speaking, let's suppose there is a method called as shallow cloning, which is provided from the library of a Java programming language or any programming language that you have. So cloning is like now a part of programming language. You don't have to manually copy each and every values from one object to another during runtime. So you would do something like, so let's suppose there is a method called a shallow clone, which is part of each object, and you can use that to create a clone of A1 into A2. Now what will this do is, like, it will create another memory space called as A2, and inside of it, it will have the values of X equals 1 and Y equals 2. So it has just simply copied and created the values inside of A2. Now what if you do A2.X equals 3? So what this will do is that it will go to that memory space and then it will change the value of 1 to 3. Okay, you can do the same to A2 as Y is equals to 4, and this is going to change the value of Y. You can do anything with this new A2 inside of the memory space. So this is what the shallow cloning is. Now let's understand what the deep cloning. So shallow cloning, again, I will state before going to the deep cloning, is creating a new object, copying the values of the old object to the new object, and then doing whatever you want with the new object without changing the values or without touching the old object memory space. Now let's suppose we will go ahead and then we will take another example. So I have an object which is called as B, and this B is an object which is like class B. So here I have two types. One is class B and one is class A. So the thing is here, B class is a class which has a one property inside of it, which is X, and A has two properties inside of it. One is the primitive type property of Y, and another is a user defined type of Z, which is of type B. Now in my memory, let's suppose in my programming, while I'm coding or programming, I create a object of type A. So it will look something like this. So as you can see here, this is the way how I've created the object A into the memory space. So A is an object inside of the memory space. It would look something like this, where we have the value of Y is equals to 1 and the value of Z is, let's suppose we have created this thing, right? So let's suppose this is represented by some reference value of BC. Alright, so Z is not going to store the entire object inside of the BC, rather it is going to store only the reference of that object. So you can see here B is also created into the memory space just like A. It's not a primitive type, so no memory address like that complete memory is not assigned to the memory space of A, rather a reference to the memory where the B has been created newly has been assigned into the Z. So Z here is now storing the reference value, which is true in Java. You can research more about it, like how the Java stores the memory reference, but here Z is storing the memory reference of BC. Now when you do shallow cloning of A to something called as AC, with the help of methods, it's a shallow clone method that we have discussed in the last slide. The shallow clone of A to AC will produce an AC which will be like AC having two values, and this is going to be BC. Now here is where the problem with shallow cloning is. If you observe here, 1 is a literal value that get copied over, that's not an issue. But here Z also get copied over, and this is storing the reference of original BC that has been created at this line. Alright, so now A and AC have different Y values, that is okay, but they both are sharing the same BC, which is created one time into the memory space, which is a problem. Because if you just simply do the shallow cloning of A to AC, then this is going to create AC, which will have a Z, which is pointing to the same B that has been created over here. So if you do AC dot Z dot X equals to 4, now this value get copied over not just to the AC but also to the A, which is like a problem, which is not like a true copying of objects from A to AC. So then we talk about deep cloning. So deep cloning is where we clone not only the parent object primitive values, but if there are user defined objects which are like a state of the parent object, then we also go ahead and recursively clone those objects and then create a new object out of it, then clone a new object out of it. So in short, deep cloning is recursive shallow cloning, where if let's suppose A is composed of an object of type B, then you will recursively compose AC but also BC. Okay, so you would have to go inside of the BC and create a clone of BC as well. So it will not just shallow clone AC, but it will also shallow clone BC, and this is how you do the deep cloning. So very simple concept, what is cloning, and now we will begin to understand why the prototype design pattern came and how cloning helps in prototype design pattern. So let's discuss about prototype design pattern. So prototype design pattern, as I told you, is similar to the builder design pattern in the sense that there are no constructors in prototype design pattern, and you do not start from, in the case of builder design pattern, you may start from the scratch, but in prototype design pattern, you don't start from the scratch after creating an object. And also the concept of setting contracts and immutability is not there. However, the structure of a prototype design pattern is rigid in the sense that almost everything that you have in an object will be copied over to the new object, whether you need them or not. So prototype design patterns are used at very specific or niche places in programming. Most of the time it has to do with the framework, where you would have one type of object and you would want to have multiple type of those objects having different states during runtime. One of the clever places where you can use a prototype design pattern is actually UI. And UI, as we know, can have a same element which can be repeated at multiple places. You can have a text box that can be repeated at multiple places. You can have labels, you can have date fields. You can have so many things that can be repeated at multiple places, in which case when you are programming those UI elements, you don't have to again and again create those elements. You could just copy those elements, change the values, and then see the result in front of you. So let's start with one UI element where we can use the prototype design pattern to improve it. But before that, let's understand that there are basically two elements of a prototype pattern. Those two elements are, so I will just PDP, which is prototype design pattern. This have two elements which are important to understand. One is the clonable item. Okay, so this is going to be like your blueprint from which you would want to clone and create more items. And another one is a registry, which is going to hold all the clonable items from which you can find out which item you want to clone and then just clone it, which is like a central registry for you. All right. So before that, let's take an example of UI element in order to understand how the prototype design pattern work. So let's start with the UI element of label. So everyone is very accustomed to what a label is. Label is basically a text that is shown anywhere on your UI. Usually label is used to describe or to tell to the user a message before any input field. So you may have seen something like enter name, and just after this there would be an input text box where you enter your name. All right. Then there could be date of birth, and then you can have a date field. Okay, and you insert the date field. So this is what labels are. Labels are basically like labels where it's a text element which you can use to give message to the user. It has multiple cases. Okay, use cases. So let's start with the help of a label and how we can employ the prototype design pattern and make our life easier when we are coding label in our UI. So let's take the example. I'll create a class of label, and this label class will have few elements such as, don't pay the attention onto the right hand side. Just take for example the label class over here. So label is a class which have a text property and a span property, which is like the width of how much width label is going to take in the UI view. And then there is something called as layout prop. So this is going to store, this is like a complex object. So I have just taken it out and created a separate object out of it. So I'm calling it a layout, and this is going to have an orientation. So orientation can be of two values, horizontal or a landscape. Sorry, the vertical or the horizontal. All right. So this is what our label is. Now, for suppose you would want to create a new label in your programming. So you would do something like, so I'm just going to write some pseudocode over here. So I will go ahead and do, okay. So this is how I'm going to create a label out of it. So this is a label that I have created, L1. This has a text of enter name and it has a layout. Now for suppose I want to create 5 labels just like L1. So L2, L3, L4 and L5. So these 5 more elements would be created in the similar fashion as I've created over here. That's a lot of manual work, as well as there's a lot of setters of values that is going into each L1, L2, L3, L4. When in the reality, many of the labels will have almost the same span and the same property, which could be the same orientation of horizontal and the same span of, let's say, a default value of 1 or 2. All right. But each label might have a different text values, which can easily be changed by just having this line of code, and then we can remove the other lines of code. We don't need these codes if we can have a template of L1, and then you can simply change those values. So if we go ahead and change it something to a prototype design pattern, the thing will look something like this. So this is how the L1 would be, and if I would want to create the copy of L1, I would do something like this. So now instead of having the same construction and then same setting of values, I have a clone method that is going to copy the values of L1 into the L2, newly created L2, and then we are simply going to change the value of L2 to text is equals to enter date of birth. We can also, so now we can think of organizing our code a little bit and introducing something called as registry. So let's suppose we take L1 as a template or the starting place which we are going to use to create L2 and L3 or any label text that is going to come forward. Then we can think of creating a template, or we can think of creating a starting point of any object, and we can start from there and create as many objects as you want. And this is where something called as registry came into the picture, where you create templates like L1 label and then you store it into the registry, and whenever you want to create L2, L3, L goes to Ln, any object inside during the runtime, then you would call and create and get a template from the registry, and you create a copy of it in the responding L1 and L3, and then change the values or do whatever you want with it. So this is what the prototype design pattern is. It's basically cloning, nothing else, but it becomes a pattern when you also introduce a registry, and registry then will start to look more in terms of a framework where you have a reproducible or repeated elements that can be reused at multiple places. And UI library again is the best example where you can see prototype design patterns in action. So post this, let's go ahead into the code and see the actual implementation and working of a prototype design pattern. So let's get started with the implementation, and I have already coded most of the stuff, so I will not be live coding it right now in this video, but you can go through this code which I'm going to post later in the video, and I will also explain them now in this video instead of coding it. Okay, so here is where the actual implementation of the prototype design pattern come into the picture. I have created a class called as label. So as you can see, label has 4 properties: a text, a span, whether it's going to be visible or not, and also a props of type props. I'll go to this class. You can see this is a property which is like x and y value, which is like telling you at what place inside of the UI you would want to show this label in. So that is what I have created a props class for. And now it has 4 properties, and these 4 properties have to be cloned. So every object in Java that you would want to have clone or should support cloning should implement this class or interface as clonable. And this clonable will ask you to implement a method called as clone object, which is going to return a generic object in Java, and it is also going to throw a clone not supported exception. So this is basically thrown when you have this method but you don't implement any cloning functionality inside of it. So what I'm going to do here is I'm going to create a copy of my current object, which is done using this. All right. And then, as you know that this properties is a separate object. So as I told you in deep cloning, you would have to recursively clone that object as well. So I'm going to go ahead and also set the properties to a cloned properties of this. So whatever props value reference I have, it also have to be cloned. So I have to now do the manual work of setting a cloned of the props value that is stored in this object. And then I'm simply returning the copy. Not too much of a typical logic that you have to follow in this case. And rest of the method, if you see, it's almost same. You have a public constructor, which you can also, if you decide, you can also like get away with constructor. You don't need a constructor at this point on. You can have a default value stored over these, but also you can have a private constructor and store some values default inside of it. You don't need a public constructor. You can get away with it. And then you have the getters and setters for this bean object. Similarly, for the props, I've done the same thing. So all the magic in prototype happens because of this clone method. If you are doing a deep cloning, as I told, you would have to manually clone the reference of the objects that this current object is pointing to. Now this is one more class called as registry. So as I told, registry is a class which is going to store all the kinds of objects you want to clone during runtime. So label is only one object with us. So here you can see I'm creating a dummy label object, or I'll say a template label object. And then I'm storing it in a hash map, which is what I'm calling a registry with the name of label. So this is a key of label which is stored inside of the registry. So you can see here the text is empty. It has a span of 2. The default value is false, and it's also having a new props value of x and y as 0. And then I simply put this registry and put a label of it as a key, and then this is pointing to this object into the memory. And then we are going to tie all of this thing together and show you how the prototype design pattern actually works. So this is what the prototype design pattern is going to help you with. If you see here, I have a registry here, so I'm creating it in this code, but registry can very well be very complex. You can also think of registry as a singleton services providing all the types of prototype objects which you would want to clone later on. And then you can have a registry access at line number 3. But here, for the sake of simplicity, I've just simply created a registry object which is going to have all the clonable objects within it. So on line number 4, I created a label L2. Okay, from the registry object, get object with object ID as label. And then on line number 5, I'm simply cloning it. This is one of the methods. This is one of the methods of doing that. Again, you can wrap it up in a different library method. Instead of exposing the clone method, you can have the same thing inside of the get object with the ID instead of having it exposed on line number 5. Again, that is left to refactoring. But what I took it out of the refactoring, I'm trying to show you that the new object L2 is then now created with L1. So if you see here, now I'm going to print some values. So here, if you see, I'm printing the value of L, and this is before I'm doing any changes to L. And this is the value of L2 I'm printing. And we'll see what all changes are there during the before time. And then I'm going to change the value of X inside of L2. And then I'm going to increment it by 1. And then I'm going to print the values of L2 over here. So I'll just play this. I'll run this method and we'll see what the values are. So here, if you see, the label before almost have the same values. The text is an empty text, both of them, because we have not changed anything, simply cloned it. But in the case of shallow cloning, you would understand that any changes to the props will also change the values in the original L. But since we have implemented the deep cloning, this is going to change only the value of L2 and not the L1. Alright, so this is what the prototype design pattern is. It consists of the objects which you would want to clone by implementing the clonable interface on them. Then you also have something called as registry, which will store all the types of clonable templates inside of it. And you would just bring them all together by creating a registry, copying the values, and then creating an object by cloning them. In a nutshell, this is what prototype design pattern is, and you can definitely discover more about this by reading the UI code of multiple frameworks where they're using the same strategy. So that is it about the prototype design pattern, which is also a creational design pattern. And if you are like me, who is like a readaholic and would like to go through each code example, I have a complete write-up of the prototype design pattern on my blog, which you can definitely go out and check. And also subscribe to my newsletter over here. I publish almost every week. And do subscribe to my channel for content like this, and let me know in the comments if something does not make sense or you would like to have some feedback for my videos. Until the next video, thank you so much for following this, and I'll see in the next topic, which will probably be the factory design pattern.